Section 4.3's focus is going to be actually on proving just specifically triangles are congruent, which is back when we first started this chapter, that was the title of the chapter. So we've kind of eased our way into it. Yesterday, you just proved any figures were congruent. And what did we have to know to prove two figures were congruent, Ms. O'Graby?
We needed to know all of their sides were congruent to each other, corresponding sides were congruent, and all of the corresponding angles were congruent. So within a triangle, there were 6 things that we needed to know.
A lot of stuff. Okay, so what we're going to find out today, and actually in section 4 as well, that triangles are kind of unique. And I think Ms. O'Graby mentioned this on one of our days, is that we're going to spend lots of time with triangles, because triangles is that kind of that really solid figure. There's a lot you can do with it. So in order to prove triangles congruent, yeah, we could prove all corresponding sides are congruent and all the angles, corresponding angles are congruent, but that's a lot of work. We're going to learn 2 ideas today and then 2 ideas tomorrow that will allow you to kind of do a shortcut. Okay, and postulates and theorems allow us to do shortcuts. All right, and you'll notice the title of the name or the title of this section kind of gives away what we're dealing with. So the first postulate is called the side-side-side congruence postulate, or for short, our acronym is SSS. What does that mean? It says if 3 sides of one triangle are congruent to 3 sides of a second triangle, then the 2 triangles are congruent.
So here we don't need to know anything about angles whatsoever.
That's kind of convenient. So notice in this picture, if I give you 3 pairs of corresponding congruent sides, so you can kind of see that segment BC is congruent to segment EF, AB is congruent to DE, so on and so forth, we're going to end up with some congruent triangles. So if I had to do a proof, we'd have to have all of these things. So if BC is congruent to EF, let me just jot that down.
Yeah. And
AB congruent to ED, and then finally AC is congruent to DF. So I have, notice, count them, 1, 2, 3 pairs of corresponding congruent sides. By this postulate, then we can conclude what?
That triangle, and I'm going to be careful when I name them. I've learned that from yesterday. So triangle, let's say BCA is congruent to triangle EFD.
Now, because they're not stating any congruent angles, you can't really name the triangle based on like congruent angles. So when you look at it, segment BC, that's what she started with here, has to match with segment EF. And then AC, so these right here should match up with the DF or FD. Okay.
Right. And another thing that I looked at I went through starting with a vertice that was between the 1 and 2 tick marks on one. So I know I want to start with the same vertice on the other one. And then because, again, I went from B through C, I went along the 1 tick mark, then along the 3 tick marks, then along the 2 tick marks. So those are kind of just some landmarks that you can find for yourselves too.
And I like how Ms. Hooker explained that. It just kind of depends on how you visualize it. I might visualize it one way, she may visualize another. I know some of you are looking at it, well, they're drawn, we try to do it where they were kind of in order anyway, but that's not always going to be the case. So just be careful with that. So when would you use side-side congruence postulate is basically when
we have all 3 sets of sides that are congruent.
So no angles, and that's what's cool about it. All right. The second one, and hopefully you looked at the name already, SAS stands for side angle side congruence postulate. And when you use a reason, all you need is the acronym. Now this one is, there's some things you have to be a little bit careful with. Obviously there's a side, an angle, and a side, so some things are going to be congruent. It says if 2 sides and the included angle of one triangle are congruent to 2 sides and the included angle of the second triangle, then the 2 triangles again are congruent. So both of these postulates prove what?
Triangles congruent.
Triangles congruent. Notice, how many different things do I need?
Oh, I still need 3 things, but here one of them is an angle. And I noticed it said included angle.
So can you elaborate on that, Ms. O'Graby?
Well, the included angle would be the angle that is between the 2 sides that we have that are congruent.
I'm going to make a note of that. I like that. So between the sides.
Yeah. So like I noticed where my 1 and 2 tick marks are, C is that vertice that's formed or that's part of both of those 2 sides. It's the one piece they have in common. So that angle C is the included angle.
So if I know segment RC is congruent to segment PZ based on this picture here, and I know angle C is congruent to angle Z, and I'm kind of going in order. Here's a side, side angle. And then the third thing I need is another segment sides. So segment CB is congruent to ZT. Then you can conclude
the triangles are congruent.
So you want to give
Let's call it triangle RCB is congruent to PZT.
And again, this order of the side, then the angle, then the side, that's really, really important, okay? Yeah. But I like, and also what Ms. Hograby said about the between. The other thing she said was the fact that you only need 3 things for both of these postulates. So it's half of the work from yesterday.
Yeah, yesterday, I remember that one proof that we did at the end. We had 6 things that we had to have listed.
I didn't love
that. You won't
that.
have 6 things anymore. You'll have 3 things.
That section, what we did yesterday, you don't have to stress over that again.
Yeah.
Kind of nice.
It's just to make sure we know what it means to be congruent. And now, notice that we're not saying definition of congruence.
Yes.
Because that is not, the definition of congruent triangles is the 6 pieces, the 6 corresponding parts. This is either side, 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 or side, angle, side. So make sure that you're using those as your reasons.
Okay, perfect. What we're going to eventually get to, which Ms. Hogarth is going to help us out, is kind of using those postulates.
Right. Okay, this first example that we have here, it says we're going to name congruent triangles if possible. So it may not be possible. We'll have to wait and see. And then we're going to state the theorem or postulate that's used. Now, looking at this picture, Mrs. Palermo, what pieces do you notice that this already has marked on it?
Okay. I see segment PL and segment MN are congruent already. And then I also see segment LM and segment PN are congruent. So I technically have 2 pairs of congruent sides, which, thinking about the 2 postulates we learned, both of those involve at least 2 sides.
Right. So that's good that we have 2 sides.
Okay.
Now the question is, can I talk about maybe their included angles being congruent, or could I talk about the third side being congruent?
Okay,
so looking at this picture, what else do you notice?
Well, I like that you said the included angle first. So the included angle would have to be angle L and angle N. Can I say those are congruent? Just say because they look congruent?
Can't say just because it looks that
so
way.
I don't know if angle L and N are congruent technically.
Okay.
But their third sides for each triangle would be, they share that side, PM.
Right. So the question is, does PM, is that going to be congruent to itself?
Yeah, we talked about this yesterday. That's that reflexive property idea. So segment PM is congruent to segment PM because of that reflexive. So I have enough information. So there are some congruent triangles because I have 3 congruent pieces, and there's 3 congruent pairs of sides.
Okay, so let's name them.
Name them. So name them if we can. So it'd be triangle. I'm going to name the first one triangle PLM.
Okay, and it's going to be congruent. Be careful with where you go.
Okay, so I'm going to do triangle M. And I'm going to go to N because I noticed PL and MN have to be the same. And then, of course, N with P. So MNP. And the reason is by side, side, side.
Perfect. All right. And be really careful with your naming. We went from P to L, so through the 1 tick mark, then from L to M, so then through the 2, and then the 3. So same thing. 1, 2, 3.
Perfect.
Okay.
Same directions. Let's see if Mrs. Hograby can do this.
Okay, here we go. I'm looking and I see a set of sides that are already congruent. I know that ST is congruent to PU. Ooh, that's a stinky one. And I know that I have a set of angles that are congruent here. I know that angle, and I can't just call it T because there's lots of stuff coming off.
Yeah.
So STU is congruent to PUT. Oh, got a little putt-putt going on.
Yes.
Okay. Now, I know that I've got a side and an angle, so I'm not going to use side, side, side because I've already got an angle. So I really want to see if there's a another side, another set of corresponding sides that are congruent. And it would have to be the included angle. So as I'm looking at that, I know I've got ST that's coming into that vertex of T where that's where my angle is. So I really need to be talking about TU. And if I look at the other triangle, I have PU already, and I'm looking at that angle with where a U is. So really I need to talk about UT. Well, TU and UT are the exact same side. So again, I can use that reflexive idea.
So TU is congruent to TU because of that reflexive idea. Okay. Something that could help those that kind of visualize this, you could separate the triangles out, couldn't you?
Yes, definitely.
So if you wanted to do that, I don't know if this is going to help everybody. Obviously, Ms. Hochgraby could do it without, and a lot of you could do the same thing. But if you redraw the two triangles, kind of just to see that here, these are congruent, these two angles are congruent, and that because Ms. Hochgraby said that the angles have to be the included angle, these sides have to be the sides that are congruent, and they're going to be because they're exactly the same side.
Right.
All right.
Okay, so let's name these triangles. And to me, it does help though when you've got them separated to name your triangles. Yes. So I'm going to go ahead and look at Mrs. Palermo's beautiful picture there and say triangle STU is congruent to triangle PUT. And that reason would be side, angle, side.
And again, guys, you're limited right now to only 2 reasons. So if you have an angle provided, then of course you're going to go with the side, angle, side. Now again, this is if possible. We might not have enough information to prove this. The other thing that I know I've gotten asked questions in the past is, do I have to write all of this stuff off to the side when I am answering a question like this? What do you think?
I would say you don't have to write the things that are already given, but other things that we didn't know already that wasn't marked in the picture, that's what we're going to need. Yeah. So we would definitely want to see this TU is congruent to TU, reflexive, so that way we know where that third piece came from.
Perfect. Thank you.
All right. Next one, it says name congruent triangles again if possible, and then state that postulate used. So let's start with Ms. Palermo, looking at this picture, what do you see? What do we have already?
Well, I already see some segments congruent. So segment AT or AF, sorry.
That's okay.
Is congruent to FB. That's already provided. And then I see a pair of angles, and I can't name it by its vertex. So I'm going to call it angle ADF and angle BDF, sorry. Those are congruent. Those are already given to us. Again, you don't have to write that down. This is just more so we can show you guys.
Right. Okay. Do we have any other stuff here that we know from our picture? Because obviously we only have 2 things. We know we need a third.
Okay. Well, one thing I noticed is those 2 triangles that are in this picture share a side. And I know when they share a side that we can say it's congruent to itself by reflexive. So segment DF is congruent to segment DF because of reflexive. Okay, so I have 3 things, so I can say these triangles are congruent.
Okay, what would be your reason?
Ooh, can't be side, angle, side, because that's not the included angle.
Exactly.
So I see a side angle relationship. Not really going to work, right?
Right. And guys, she said side angle, and I'm going to write it that way. Because otherwise it could be bad.
Because if you write it wrong, I see it.
Now, I'll tell you guys that here's our clue. We will never use bad words in geometry. All right? We are not going to have a way to prove triangles congruent that would require us to write bad words on our papers. That would be awful. We
are G-rated.
We are G-rated. So we're going to go ahead and that's not going to be a reason. You're right.
Yes.
And it's not the included angle. I love that she mentioned that. If I had known that these were the angles that were congruent, then absolutely I could say that these triangles are congruent. But because it's not the included angle, no. We just cannot state that it's possible.
So it's not possible or something?
Not possible.
And yes, guys, they kind of look that way. We purposely did that. It's more you have to kind of look at those kind of where's the angles, where's the sides, things like that. All right, I think we have one more like this, and then we'll move to some different types of problems. So first of all, I do see some things off to the side. They didn't label any of this, so let's label. So segment AB, so showing this whole segment is congruent to segment BC. And then segment BF, so this little guy right here, is congruent to segment BE. Now, first of all, notice there's more than one set of pairs of triangles. You see that there's several.
I see a lot of triangles. I think this might be a good one to go ahead and separate, just because there's a lot of stuff
now,
going on.
how do we know which triangles they're talking about then?
Well, if they're using BA as a side, then I'm guessing BA, and then BE is also another side. So triangle BAE is one of our triangles. I'm seeing it.
Another kind of giveaway. Another kind of giveaway. Notice they didn't even label this vertex here.
Right.
So if I don't know the name of this vertex, then we can't talk about triangle AF. What? We don't know. Okay. So, but I like how Ms. Hogre said, since they're giving you information about some things. So triangle ABE, so that's congruent, has 1 tick mark. This has 2 tick marks. I'm going to draw the other triangle. Not the best drawing there. Sorry, guys.
I think
this
it's
is
beautiful.
a sketch.
All right.
So segment BC and then BF had 2 tick marks.
Okay, so now I'm seeing it. Oh, and now I can tell I've got 2 sides already.
So what's your option?
I could either talk about that third side.
So that would be
AE.
stating AE and FC. Is there any way to say AE and FC are congruent?
No, there's not. But I do see the included angle. They're both angle B. And if I look back at the original picture, it's the same angle in both of them.
So this angle B can be congruent to angle B.
Okay, so sides can be reflexive, but angles can also be reflexive.
Yep.
Okay.
So when they share the same side or share same angle, that's going to be something you're going to always write down.
Okay. So now I already see we've got 3 things that are marked as congruent. We've got 2 sides, and they are the included angles. So I can name these triangles. Triangle ABE is congruent to triangle CBF.
And notice how she's matching the pieces together. And what's the reason?
That would be side angle side.
Good. All right, let's try a different type of problem.
All right, this one, it says, what other piece of information is needed to prove that these 2 triangles are congruent using the side angle side congruence postulate? All right, so that means that we have some things already. And notice it says, what other piece?
So that means just one.
So it just means one piece.
Okay.
So that means that there's something else that, because right now, what do you see that's marked on the picture?
Well, we already know segment GI and segment IM are congruent.
And that's given to us. So that's the one piece we know.
Okay. Now, technically, it's not necessarily given, but we know that those 2 triangles share common sides. So that segment IH or IHI, those are congruent anyway based on reflexive.
So that is not something we need to be given in addition?
Yeah, we can
because
say
we
that.
already know that.
We say that from the picture.
Okay. So these are the 2 things that really technically we are already given.
No.
There's one other piece though that we don't know yet. And if I wanted to use side angle side, I need it.
Okay. So if I had to use side angle side, I would need an angle that's included between the 2 congruent sides. And I'm seeing that angle GIH. So that angle there, so angle GIH, and has to be congruent to angle HIM. So the included angles. So if I gave that to you, or you were able to somehow prove that, then you could prove those triangles are congruent by side angle side.
Right. So notice this one, we had a piece that was already marked. Another piece that we technically are given because of the picture. And there's a third thing that we needed. And that third thing we needed was the set of angles that were congruent. And then we could, you're right, prove it.
So these are good. This is a good question just to kind of think about this postulate. Like, what things do I need? Because when you start doing a proof, which we're about to do, that's the things you want to start thinking about.
Right.
So let's do a proof.
Okay.
So let me write down the given information.
All right. And I'm going to start talking while you're writing that
Perfect.
down. All right. If we know that AB and BC are congruent and D is the midpoint. Oh, we haven't seen that word midpoint for a while. Midpoint, we know, forms 2 congruent segments. It is the middle point. That's what everyone always wants to tell me. But the definition of a midpoint is that it divides that segment into 2 congruent segments. So I'm going to go ahead and, off of that D is the midpoint of AC, I'm going to define that.
Okay.
Because I see a vocabulary word.
Perfect.
So I'm going to say that AD, segment AD, is congruent to segment DC. And that's the definition of midpoint.
Good idea.
All right. Now
I'm
I'm looking
label.
and I see, yeah, that's a great idea. I'm seeing that we already have 2 sets of sides marked as congruent. So as I'm looking at that, I want to see, okay, the third sides, are they congruent? And oh, yeah. I'm looking at BD. They share that common side. So I know that BD is congruent to itself, obviously.
Good. So if do I have to put that in the proof?
We do, because here's the thing. When we're doing a proof of this stuff, we need to show 3 sets of congruent pieces.
Okay.
And so we already had 2. We know we need to show that third, even though it's an obvious kind of no-brainer one, we need to show that reflexive property.
So the reason is it's not given to us, it's because of that reflexive property.
Right. And now I've got 3 congruent statements, and they're all 3 sides. So now I can say that the triangles are congruent, and I obviously want to name them the way that they've asked me to name them in my step that says prove this.
That's helpful, yeah.
That is very helpful. And my reason is side, side, side.
And I like that she was thinking about what's the other option. I already have 2 sides. Either I'm going to get another side, which she saw right away, or the included angle. Now, if you were thinking included angle, that would be this angle A and angle C. And we don't have information right now to be able to prove that.
Right.
Okay, so that's why and since they're trying to tell you to prove congruent triangles, that means they're going to be. So you have to have the information. So notice there's 1, 2, 3 pieces of information that are going to be congruent to prove the triangles are congruent every single time.
Okay. This next one, we've got a couple triangles here, and I'm going to start writing down my given information. I'm going to let Mrs. Palermo start thinking.
All right, so she's writing down a segment AD is congruent to CB. So there's already 1 piece of congruent stuff. So that means I need 2 more already. And I could either come up with 2 more sides or another side and an angle. There are also some parallels. So if you label that, notice the sides that are congruent are also parallel. I'm thinking back to last chapter, and I remember when we talked about parallel lines, or parallel segments in this case, that automatically meant that we had some special angle pairs that could either be congruent or supplementary. And the fact that we're trying to prove congruent, then we're probably going to say something about congruent angles. Probably.
Right.
Okay? Now, the way you could start this is either way. I'm going to feed off of that parallel just because I'm talking about it. All right? So when I look at it, I see segment AD is parallel to segment BC. I see that they have a transversal AC. So if she can, yeah, I like that she's doing this. Segment AC cuts both of those. And I see some alternate interior angles.
Mm-hmm.
And
what are they?
Now there's a couple alternate interior angles, but the ones that are going to be helpful to us because of those are the only ones parallel are angle DAC and angle BCA. So those are going to be congruent.
All right. Now, I love that you kind of emphasize there are other alternate interior angles here. Now, notice the other alternate interior angles would be like saying this angle out here and this angle all the way out here. They have to go all the way to the parallel. That's cutting off part of my figure. So that's obviously not going to be very helpful. If you notice when you're trying to do these, be careful not to just go to the edge of the side. Make sure you're thinking all the way up to the parallel, from that transversal all the way up to the parallel. That one's not going to help us on this problem.
And if you're thinking, because I know some students do this, is sometimes they think, well, what about angle BAC and angle DCA? Those are alternate interior angles for segment AB and DC, and we don't know if those are parallel. That wasn't provided to us. All right, so my reason for step 2 is because of AIAT. Okay, and so now I have a side and an angle.
Oh.
Delete the whole thing.
Don't want to get rid of all of it. Oh, I'm going to just leave that
Yeah,
line.
I think that's a good idea. It's not really messing us up.
It's not messing us up.
All right, so I have a side and an angle, so that means I probably need a side. So my third piece, well, they share a side.
They do.
So can I just say segment AC is congruent to segment AC? And my reason would be because of reflexive. Now, because you can flip-flop steps 2 and 3, and some of you might do that first. I think that if you see this common side or common angle, sometimes I think that helps students to write that down right away, and then that helps you guide where you're going to find next. Now that I have that, I can say the triangles are congruent because of side, angle, side.
Again, notice I'm naming it just the exact way that they had it named too. And side, angle, side. And notice again, it was the included angle. Always look to make sure it's the included angle. So side, included angle, side. Wonderful.
Last one. I see that word midpoint again, Ms. O'Grady.
Yes,
so
midpoint.
You
Okay.
helped me really well on the last one, so I'm going to go ahead and start writing down.
All right, and notice that's all we're given. is that W is the midpoint, but we're given that it's the midpoint of two separate segments. So I've got a few different, really two different congruent statements that I can make when I'm given that. So I'm going to start off with W being the midpoint of VY. And looking at that, I know that that divides that segment into two congruent parts. So VW is congruent to WY. And knowing that it's also the midpoint of ZX, I can say that ZW is congruent to WX. And it's both because of definition of midpoint. So I love that we put them all in one step.
All right, keep me going.
Okay, we've got two sides. We either need the third sides.
So could I say V?
Yeah, I don't know anything about those. And I can't really talk about, I don't know anything about them.
No.
But I could do the included angle because I noticed they're vertical angles.
Oh.
Okay, and I can't call it just W because there's lots of things coming off W. So let's say angle VWZ is congruent to angle XWY.
It froze on me, sorry. I was waiting patiently and then it just stuck.
Oh, and it's not undoing it either. That's all right.
So this is a big angle.
XWY.
XWY. Sorry.
And that reason is the vertical angle theorem.
Now, something I want to comment on this is because this is one a lot of people make a mistake on. I've seen this in the past years.
I have too. I know exactly
what
you're going to say.
Some students want to say angle W is congruent to angle W a lot of the times because they're wanting name by vertex. And a lot of times when you say that, you're like, well, because they're reflexive, because it's the same angle. These angles are two different angles, but we know they're congruent because of the vertical angle theorem. So be very careful. None of that doesn't change from what we've talked about before.
Right.
Okay? We're still using those same concepts. All right, keep going.
Okay, I've got two sides, and I have their included angles are now all congruent. I've got all three congruent statements, so now I can say that those triangles, triangle VWZ is congruent to triangle YWX, and that reason is side angle side.
Now, I want to go back to Ms. Hograby mentioned also that the given did not provide any congruent stuff. So that's why this is one where we actually had to prove all three congruent pieces before we could do it. Whereas the other proofs, they gave you at least one piece. So that's something also, if they're not giving you congruent stuff, you need to have to make sure you do all three things.